Hello everyone, this is going to be our last lesson for this week. I usually teach this over 2 days, but I'm going to go over again like I've been doing for all the other worksheets and assignments that I've been giving you guys for right triangle trigonometry so far. I'm going to do a lot of these as examples, and then your job will be to finish up the worksheet. So what we're going to be looking at is two parts: solving right triangles. So when you're asked to solve a triangle, you're asked to find everything that's missing. So if it only asks for one missing piece, which will be the case when we go to start this out, we'll just find that one missing piece. But if it says solve the entire triangle or just solve the triangle, that means we need to find all the missing sides and all the missing angles. So that's part one of today's lesson. Part two is sort of shifting from right triangles to just any type of triangle, which we call oblique triangles if it's not a right triangle. We're going to look at how to find the area of a triangle when the height is missing. So I'll talk about the formula. We'll come up with a new formula for when the height's missing, and then we'll just keep using that. All right, so this is problem set 3. I'm going to do one example, at least one example from each little section that's here. So it all depends on what's missing and what type of triangle we're given from here on out to help us determine what the right process is to find it. So for 1, 2, and 3, notice these are all right triangles. It just says find the length of the unlabeled side of the triangle, which means we're just going to use what, guys? Pythagorean theorem. So go ahead and just pause the video. You guys calculate number 1. For this, let's just go ahead and, as we were doing actually in the past, let's get the simplified radical form and the approximate form. So go ahead and pause the video, figure this out. It's good review, and then continue playing to see what your solution is and if it matches mine. All right, so we're going to use the Pythagorean theorem here. We need to find the hypotenuse. So also carefully look to see, is it a leg that's missing or hypotenuse? And in this case, it's the hypotenuse. So I'm going to just start with, I'll write this up here, 4 squared plus 8 squared. Doesn't matter what letter we call it, so c squared. So 4 squared is 16, 8 squared is 64. So adding those together, we'll get 80. Taking the square root, so c is going to equal radical 80. Now 4 goes into 80, that's 4 times 20, but 20 can also, or also has a perfect square factor, so I want to find something larger. So I'm going to try 16, and it's actually 16 times 5. So c is going to equal the square root of 16 times 5, which will now become 4 radical 5. So that is the exact value. And we'll round to the nearest hundredth here. So then c is approximately 8.94. So again, this is the exact answer in simplified radical form, and then the second part is the approximate. All right, so 1, 2, and 3, we're just using the Pythagorean theorem very carefully. All right, now in 4, 5, and 6, notice the numbers are showing up down here. We need to find the missing angle. It says find theta. Remember, as I mentioned, theta is a symbol that represents a missing angle. So based on what's given here, I don't necessarily need to find all 3 sides. In order to use the trig ratios, all I need are 2 sides, but I need to know which 2 sides. Now notice this one sort of switched around. That's why I chose to do this one as an example. My right angle is right up here, so the hypotenuse is always the side that's opposite the right angle. So this 2 is the hypotenuse. If theta is right here, this radical 3 is one of the legs. This is the side that's opposite my angle theta, and then this missing side is adjacent, so I don't need that. The 2 sides that have numbers written in, that have measurements here, is opposite and hypotenuse. So let's think back. What trig ratio compares opposite over hypotenuse? If you're thinking the sine, that's correct. So I'm going to set this up as sine theta is equal to radical 3 over 2. Now this was from yesterday's lesson. We need to use the inverse sine function to help us out. So theta is going to equal the inverse of sine of radical 3 over 2. And all I need to do is type this into the calculator. Like I said, eventually, hopefully we'll be able to get to this part. We'll be able, my job will be to get you guys to know what's called the unit circle, and then we will be able to know what the inverse sine of radical 3 over 2 actually is. So again, please make sure if you didn't change anything, your calculator should still be in degree. Go ahead and calculate that. I'm going to show this on mine as well. All right, so again, we want the inverse sign, square root of 3. Make sure you're out from underneath the square root when you go to type this in. Over 2 gives us a nice whole number, so we're getting 60 degrees as this answer. Make sure you label this as degrees. All missing angle measures should be degrees. If it's a missing side and it's not labeled, that's fine, but if it does show centimeters, meters, or inches, make sure that you're labeling it the same way. So in 4, 5, and 6, all you have to do is figure out which trig function to use, set up the trig ratio as I did here, and then show this step that you're using the inverse of that as well. So those are the 2 steps I'd like to see. It's also very helpful if you label the sides that are given to you as opposite, adjacent, or hypotenuse appropriately. All right, notice for 7, 8, and 9, it says solve the right triangle ABC for the given conditions. Now in these 3 examples or problems, the triangles are drawn for us, and others, they're not. We're going to have to make a quick sketch of a triangle to help us fill the missing pieces in, but just to make it a little bit easier, let's write them all as A, B, and C. Notice all the angles are capital letters, all the sides are lowercase letters. So for number 7, we need to figure out, we can't just jump it right in and determine, like, do we have to use a Pythagorean theorem? We have to figure out what's our best bet here. So notice only one side is given, so we can't start with the Pythagorean theorem. We would start with that if 2 of the 3 sides are given to us. So what I first need to find, if I'm given an angle, I need to use that. It doesn't really matter which side we find first. I'm going to go ahead and just find side B first. All right, so I want to do this, and some of you might be thinking there might be something else we could find very easily, and we could do that in any step. But I want to find side B first. So basing this off of angle A, the side that's 10 is opposite, and then B here is my adjacent side to my angle. So opposite over adjacent is which function, guys? If you're thinking tangent, you're thinking correctly. So I'm going to write this as tangent of 42, we know our angle, we don't need theta, is equal to opposite, which is 10, over adjacent, which is B. So now my B is in the denominator, so all I really need to do is kind of switch 2 things around, but I'm going to do this step by step. First, I want to just multiply both sides by B to get it out from underneath the denominator there. So I'm going to have B times tangent of 42 degrees is just equal to 10. Now to get B by itself, I just need to divide by tangent 42. So B is equal to 10 divided by, and very carefully make sure that tangent of 42 is going to be in your denominator, is going to be in parentheses there, just so we don't make any mistakes on the calculator. So go ahead and type this in. And again, if your calculator is still giving you, most of the time it's just the CAS that does this, but if it gives you this format, all you have to do is go back up, hit enter, then hit control enter, and it's giving us our value here. So we're going to round everything just to the nearest hundredth just to be safe. So we're going to say it's about 11.11 as our length here. We're not given centimeters or any kind of unit of measure. So B just has a length of 11.11 units. All right, so there's one answer. Now, as you're doing this, because you're going to have work, a lot of work for each problem, just go ahead and box this in. So we have side B. What else are we missing? We know 2 angles. We know angle C is 90 degrees. We know angle A is 42 degrees. Angle B we can find. And anytime you go to write this out, just say angle B. You could put the little m in front, the measure of angle B. Now, what do you know about the angles inside a triangle? What do you guys remember? If you're thinking that they all add up to 180 degrees, you're correct. So because this is a right triangle, we could just take that first 90 away. So the other 2 acute angles of a right triangle should also equal 90, because if we took these 2 angles A and B to be 90, then we have the other 90. So only when it's a right triangle, all we have to do is subtract the given acute angle from 90. So 90 minus 42 is going to give us 48 degrees. So again, the way I figured this out was I knew that angles A and B should equal 90 degrees. So if A was 42, B would have to be 48. So I'm going to box this in as another one of our answers. And then all I have left to find is side C. So next we want to find side C. Now there's a couple ways you could do this. You could use another trig value here, or a trig ratio, but now that we have two of the three given sides, we could absolutely use the Pythagorean theorem. Now just know, because we rounded side B, we're going to be off a little bit, but that's okay when we go, if we go to check using the Pythagorean theorem. But we could just say that a squared, which is 10, so we could say 10 squared plus b squared, which is 11.11 squared, would equal our hypotenuse, which is missing. So we're going to get 100, just squaring 11. Now you could just type all of this into your calculator. Otherwise, it's going to give us a rather large number, but I'm going to write this all out. We're going to get 123.4321. Add that together, so we're going to get 223.4321. And then carefully take the square root of that. And I said it, but I didn't write it. 223.4321. All right, and you should be getting like a 14.947, so we'll say it's approximately 14.95, and we'll box that in as well. So anytime we're looking at a triangle, we should be given three things. We're given three angles here, or three measurements. We're given one angle, or two angles actually, in one side. So angle C is 90 degrees. And then we have to find two of the remaining sides, and then the one remaining angle. So there's always 6 parts to a triangle. 3 angles, 3 sides. 3 of the pieces need to be given to us to be able to do anything. All right, so there's example 7. Let's now take a look at example 11. All right, so here now we are not given a picture, so it's going to be very helpful to first maybe just make a sketch. It could be any size. Now these are all going to be right triangles for today's lesson, except when we get to area. So again, let's always label the two acute angles A and B. Let's always make the the right angle C. That way when we go to label the hypotenuse here, that could be the lowercase c. So let's write in what's given here. And again, my sketch doesn't have to match my angles right now. It was just a way to get started. So I know angle A is 51 degrees, so I'm going to write that in here. And side C is 5. So that means side C is over here. So this is side A, this is side B. Now, like number 7, we can go ahead and find angle B right away. So we'll say the measure of angle B. All I need to do is take 51 and subtract it from 90. So this is going to give me 39 degrees. So I'm just going to show 90 minus 51. So I'm going to get 39 degrees for the measure of angle B, and we'll box that in. Okay, so again, I don't have two of the three sides, so we can't use the Pythagorean theorem just yet. I have to use a trig value. Now, because we do have angle B, we could really start with anything, but I'm just still going based off of what's given here. So let's go ahead and find side A first. So if you notice, I have angle A, so side A is going to be opposite, and I have the hypotenuse. So what trig ratio or trig function relates opposite over hypotenuse? And that would be sine. So I'm going to write that sine of 51 degrees is going to be my opposite, which is A, over my hypotenuse, which is 5. So now to solve for A, all I have to do is multiply both sides by 5. Times 5 times 5. So I'll write it this way, that A is equal to 5 times sine of 51 degrees, and then this will give me my approximation for side A. So let's go ahead and type this in. So we want 5 times sine of 51. And again, go ahead and hit Control Enter, and we're getting about 3.89 for side A. So here is our second answer for side A. Now that we have side A, we could just use the Pythagorean theorem to help us find side B. But notice our hypotenuse is given, so we're going to take 3.89 squared plus b squared equals 5 squared. You guys go ahead and pause the video and calculate this. I'm just going to write this step out. 3.89 squared, I'm just getting to be a 15.1321 plus b squared equals 25. So I'll subtract 15.1321 from 25. So b squared equals 9.8679. I don't want to round until the final step. And taking the square root of that, b is approximately 3.14. All right, so an example of where we have to draw this triangle out, fill in what's given here. So we'll do 2, maybe 3 more from this page. All right, so 13, go ahead and pause the video, draw your right triangle, label what's given. And actually see if you could find everything that's missing before you come back and hit play. All right, so angle B is given here at 31.7 degrees, and side A, which is right down here across from angle A, that's 9. Remember, the lowercase letter is always opposite the angle that we're trying to write in. So this is side B, and this would be side C. So just like the other two examples, we can go ahead and find angle A first. So the measure of angle A is just going to be what, guys? 90 minus the 31.7. All right, so we're getting 58.3 degrees for the measure of angle A. So there's our first answer. All right, now again, we have both angles A and B, but I'm going to base this off of angle B. So side B is going to be opposite. Let's find that first. And then I have side A that's given here, so that is adjacent. All right, so I'm going to find B next. Find side B next. So I'm given opposite, or I have, or side B is opposite, and I'm given the adjacent side. So opposite over adjacent means which trig function? That would be tangent. So we're going to set this up as tangent of 31.7 degrees is going to equal opposite. So that's going to be B over 9. So just like number 11, to solve for B, I want to multiply both sides by 9. All right, so B is going to equal 9 times tangent of 31.7 degrees. We'll type that into our calculator. And we're getting a 5.56. All right, so there's our answer for B. And for C, now you guys can see how much space this is taking up, but I am also writing rather large. So your best bet, if you could write neat enough, if you print this worksheet out, please do so. But if you are finding that it's taking up more room than what I'm giving you here, please do all this on a separate sheet of paper. But yes, we could just use the Pythagorean theorem to find side C. So we're just going to say 9 squared plus 5.56 squared equals C squared. So we're going to get 81, squaring 5.56. You get 30.9136. Leave this in here for C squared. I'm just going to add that together and take the square root of it right now. So C squared is actually equal to a 111.9136. So we'll take the square root of that, and we should be getting a 10.58. So C is approximately 10.58. So we found all 3 missing parts. All right, so again, I just wanted to give you guys enough examples where we had to start with a trig value first, where the angle was given. So it was very easy to find the third missing angle first, and then use that to help us find the 2 sides. Now it changes a little bit in number 15. Here we're given 2 sides. So again, I'm going to go ahead and just draw a right triangle off to the side. As always, I'm labeling the 2 acute angles A and B, and then the right angle is going to be C. So now we're given side A is 12. So side A is always opposite angle A. So here's 12. B is 8, and then C is the side that's missing. We don't have any angle measures right now. We have 2 of the 3 sides, so we're switching gears a little bit. Our very first step, we have no other choice, is to use the Pythagorean theorem to find side C first. So we're just going to say 8 squared plus 12 squared equals C squared. So we get 64 plus 144 equals C squared. You guys finish solving that there. So we're going to get C is equal, if we add these two together, we're going to get 208. So I'm just going to say C is going to be the square root of 208. Now 4 will go into that. So let's see. That should give us a 52, and 4 also goes into 52. So go ahead and divide 208 by 16, because 4 and another 4 go into it. So we have 2 factors of 4, which should make 16, which is 13. So this becomes a square root of 16 times 13. So C is going to equal a 4 radical 13, which we could approximate as well to be about 14.42. which is approximately 14.42 units long. So there is side C. So next, it doesn't matter which angle we find. I'm going to find angle B next. So I'm going to mark theta down here. That doesn't come out too great. I'll just mark it. Instead of theta, I'll just mark my arc right there. So I want to base this off of angle B. So my side, that's 8. That's my opposite. Now, even though I have all 3 sides, C was an approximation, or it has a radical, so let's not use that. It's not impossible, but we want to work with easier values. So I'm going to use the side that's 12. So this is our adjacent. So that's going to be tangent again. Tangent is equal to opposite over adjacent. And again, guys, I'm getting all of this just from going back to SOHCAHTOA as a way to help. So tangent is opposite over adjacent. So I want to set this up as tangent. You could use theta if you label it in your picture, or just B, angle B is missing. And then this is going to equal 8 over 12. Opposite over adjacent is 8 over 12. I don't need to simplify this here. What I need to use, though, is the inverse tangent. So we're going to say B is going to equal the inverse tangent of 8/12. And then all we have to do is use our calculator. So going back, we want to go to inverse tangent and just type 8 divided by 12. And we'll get our angle measure here. So 33.69 degrees. 33.69 degrees. So I'll just put angle B is equal to 33.69 degrees. And we have our angle measure here. Now to find the other missing angle A, all we have to do is take 90 and minus the 33.69. So angle A is just going to be 90. I mean, we could use trig again, but this fact is also making it a lot easier. 90 minus angle B, which is 33.69, is giving us an angle measure here of 56.31. 56.31 degrees. So here is angle A. All right, so a little different here. We were given our 2 sides first. We had to still just use one trig value, but inverse now. Once we find that, we subtract that from 90 to find our other missing angle. All right, so one thing I want to point out, whenever there's going to be 3 cases, and I'm just going to use this as an example. Let's say we have sine of A is equal to 3/2. To find a missing angle, we're going to use the inverse. So whenever the angle's missing, that's how we find it. If we are given an angle measure, so let's say we have sine of 58 degrees, and then that's equal to, let's just say 10 over B. To find this, you could simply switch these 2 values around. So then we're going to say that B is just going to equal 10 over sine of 58 degrees. So whenever your variable is missing and it's in the denominator, in a way, we're kind of skipping a step, but all you first have to do is multiply both sides by B, then divide by that sine of 58. So it ultimately will just turn into you switching these 2 values around. And then the third case is if our variable is in our numerator. So let's say we had sine of 58 degrees, and then that's equal to B over 10. To find b, all you have to do is get rid of this 10. So b is going to be 10 times sine of 58 degrees. So those are your three cases of where your variables can be or what's missing when you're using trig functions. All right, so this next part I want to show you is going to help us find the area of the given triangles here. So I'm actually going to do a separate example on the last page here, and then you guys are going to have to go back and finish these three. What we do is we just come up with another formula. Notice these are not right triangles, so I'm going to emphasize that here. Not right triangles. Because, and you'll see once we're given a formula, if we're looking at a right triangle, you could just always use the formula because you need the base and the height. The base and the height always need to be perpendicular, and in a right triangle, the two legs are always perpendicular, meaning they form a right angle, so there's no need for this alternate formula here. But if you notice, in all three triangles, they're not right triangles, and the heights are not given here. We have a base, but in 22 we don't even have a picture. We're going to have to draw one. So let's go ahead and try this though. So I'm just drawing a random triangle right here. The height is missing. So how to find the area of a triangle when the height's missing? So the formula for area of a triangle is 1/2. I'm just going to write this out in words. Times your base times your height. And the base and height are always perpendicular. So in this picture, x is my base. My height is not y. The height has to be perpendicular. So my height is going to go right up from my base. It's going to be perpendicular. So I'll call this the height. And it's missing. So when we don't know it, we're going to have to use some trig to help us out. So notice I labeled an angle here of theta. Now to find my height, which I'm just going to call side h, it's the side that's opposite my angle. And I'm also going to draw a right angle mark on this side. Now notice the side that's y of this triangle. I'm going to outline this in purple right here. Of this triangle that I just formed, I created a right triangle. It's a little wavy there. But side that's y, that is the hypotenuse. So in this case, the height of this triangle, I'm going to use a trig function. It's going to be sine of theta. Actually, let me write it this way. If I were to write out sine of theta, because I have opposite and hypotenuse, sine of theta is going to equal h over the side that's y. So I need to solve this for h. So all I have to do is multiply both sides by y. So h is going to equal y times sine theta. And that's what I'm going to substitute up here for my height. So my area formula now is 1/2 my base, which is x, times my height, which is y sine theta. So this is now a new formula for area of a triangle when the height's missing. Now notice, if I were to take this away, notice the original of what I had here. These two sides, x and y, show up in my formula. They are the two sides that form my angle theta. So this is our formula right now. So let me just make an example up. Let's say we have a triangle. I'm going to call it, and I'm going to do one that doesn't have a picture like that very last one. So I'm going to call it triangle X, Y, Z. And let's say angle X is going to be, let's make it 88 degrees. Now, if the angle's given here, notice the two sides that would form my angle, even though I'm using theta here, the side that is opposite my angle is going to be the same letter. So the other two sides are not going to match that letter. So that means I'd have to be given sides y and z. So let's say y is side y. Let's say it's just 15 centimeters and z is going to be 20 centimeters. So all we have to do is use this formula here. So area is just going to be 1/2 my 15 times my 20, and then times sine of 88 degrees. So I don't even need a picture. All I need, and what I'm going to give you, are the three values that we need. So all we have to do is type this in and we'll get our area of a triangle. All right, so let's go ahead and type this into our calculator. I'm just going to use a 0.5 as 1/2 times 15 times 20, and it's always going to be sine, as I just generated that formula for you. So it's going to be times sine, and we have what, 88 degrees. So I'm getting an area of 149.91, and it's going to be square units in this case. So 149.91. Area is equal to 149.91, we'll say square units. And this is important because you're not always given, if you're looking at a room and trying to get the height of a room, you would just measure straight up from the floor to the ceiling. But let's say you had a triangular garden and you were trying to calculate area of this. If you didn't have a right triangle as the shape of your garden, you could figure out the area just by knowing two of the sides and then an angle measure as well. So that's not always the case, but this is one way to figure out area. All right, guys, so your assignment is to finish the remaining problems off of problem set 3 and turn that into me by Friday along with problem set 2. As always, stay safe and let me know if you have any questions.